That's right, folks, it's a little bit of a special presentation. I was originally going to be doing part 4 tonight, where we were going to be diving into development on the MS-DOS side of things, and we're going to get to that, but I was just at Tandy Assembly almost 2 weeks ago, as evidenced by this wonderful t-shirt you'll see more of throughout the video. This is a Tandy 6000 because this year is the 40th anniversary of the release of the Tandy 6000, one of the 8-inch business systems. In fact, not only did they have these cool shirts with the Tandy 6000 theme, but they also had a really tasty cake that looked like a Tandy 6000. It was probably about half the size of one, too. And a lot of other great things happened at Tandy Assembly. We'll get into that. But for this video, one of the highlights for me from Tandy Assembly, aside from, meeting people and presenting about the VIS, was that I had delivered to me a little bit of a loan out. The unicorns have landed for the VIS, and we are going to spend the next bunch of months over the course of my next few videos kind of digging through what I've been lent, and I'm really excited to show all of you. So what the hell is it that I have? Well, let's take a look. And here they are, friends, unicorns galore. These are the original Tandy development cards used to write software for the VIS on a PC, giving you a close VIS analog on your PC-compatible system, generally speaking a 286 or later. Now, these cards are undocumented. I don't have any documentation with them, so you're going to be going along with me as I try and figure out how to get these to work and how to make them work. And then as we do, we'll try and incorporate them in my future videos when we talk about developing for DOS and some of the other stuff we're going to do with the Save It card. But in the meantime, I wanted to walk through each of these cards tonight, and we're going to talk a little bit about them. Now, as far as we know, there are tens of each of these cards, if that's still in existence. These were the cards used by developers, and I'm imagining when VIS tanked, a lot of developers chucked them in the trash. So either way, there are a few known on hand, a few folks in the Tandy community have them, including Tandy Showcase, from whom these cards have been very generously lent. And I thank Tandy Showcase for his generosity and for allowing me the opportunity to experience these cards for the next few months and try and play with them. So we're going to learn about them, we're going to try them out in my Tandy 4833 LXT Franken Tandy. Now, we're going to use these in addition to the standard method I've been using to develop without the cards, because let's face it, folks, these things ain't getting remade, and we're going to want to be able to develop for the VIS without them. So I'm going to show you what I've been doing up until now when I've had these cards, and then we're going to try these out. So we're going to take a look at each of the cards here really quick. We're going to talk about them and just see what it is they do. I know I mentioned them briefly in a previous video, and I showed pictures of them, but tonight we're going to take a closer look, and then when we're done with that, we're going to take this card right here, the serial loader and debug card. We're going to install it into my VIS, and then we're going to attempt to get some data from the VIS to it using a shell-like application for the VIS that happens to have a logging mode. This card can be used to load software on the VIS. It has a ROM on it, which I have dumped. I don't know if that ROM is going to make the VIS boot behavior be any different. I've not tried it, so you're going to be right there with me. So all right, let's take a look at each of these cards. And first up, we have the aforementioned serial loader card and its companion riser card. As I'm sure you're well aware by now, the VIS is in a little set-top box configuration, so it's not very tall, but the expansion connector on the VIS sticks straight up out of the main logic board. This serial loader card wouldn't fit within the VIS's case, and so the card is mounted sideways within the chassis, as you'll see in a few minutes, and the riser card extends the bus up so that it can sit sideways and allow the card to fit into the case and put the cover back on without having it stick out or do anything funny. The serial loader card has a ROM on the left, which who knows what's in it. I did dump it, as I mentioned before, but it's supposed to allow the VIS to load code from a PC. Now, whether that's after there's an operating system loaded or whether that's an additional addendum to the boot process, we'll find out. In fact, when I put the card in, maybe the VIS will act a little differently. There is a shell-like utility, as I mentioned, for the VIS that will allow us to log out to the serial card. And so what we're going to do is get my DT100 connected up, and we're going to try and log some command input-output using that shell-like utility, and we'll talk a little bit about that shell-like utility. Otherwise, this card is a standard serial port, and it is configurable as COM1 or COM2, which are the only two COM ports that the VIS supports. And next up we have the modem. This is the same modem that was used in the original Tandy Sensation, the one released in 1992 for the 1993 catalog, catalog number 25-1650. This is a 2400 baud modem with 4800 fax capabilities, and you can see that it connects to the motherboard with this little Mylar connector, and there's a small connector on the motherboard that extends the lines necessary up. Now, the entirety of the UART and the modem circuitry is on this card, so there's not a UART or COM port on the main VIS logic board. You have to connect this board to get any kind of UART functionality even for the modem. In a future video, we will be installing this in my VIS, and I might try and whip up something quick to try it out. There's no Radio Shack software that supports this, but I think it would be a really cool thing to try and play with. Maybe get it to dial into another machine, or even better. So we're going to be revisiting the modem. It will be going in the VIS, but I will not be installing it tonight with a serial debug card because I don't know if the two can coexist and get full functionality from the serial loader. And again, same modem is used in the Tandy Sensation, so if you had a VIS and a Sensation, you could borrow the card from that if you wanted. Next up, we have the IR receiver expansion card. This card is used to allow the IR hand controllers to interact with your PC. Interestingly enough, there are no direct receivers on this. Instead, there are two small DIN connectors to which I assume infrared LEDs or receivers would have been attached. Again, we don't have the documentation for these cards, so I don't know exactly what they do or how these were meant to be connected. We don't have a pinout for these yet. Hopefully that'll surface. There's one set of jumpers on this card that allows you to change the interrupt from within the PC. Now, when I set up my 4833, I do plan to install this card, but I don't know if we're going to be able to get any use from it unless I can figure out how to connect some sort of LED receiver to it, or infrared receiver I should say, so that we can try out the VIS cards. Now, it may be possible too that those are PS2 ports and a PS2 hand control could be used, but I do not have a PS2 hand control. So either way, we'll see what happens with this, but this may or may not be something we get to play with. I do plan to install it anyway, just to see what happens. Next up, we have what I think is going to be the star of the show as we're experimenting with these cards, the Save It card interface and CD-ROM interface. This is combined into one card. It does have two jumpers on it, one to set the interrupt, and I believe the other one is the DMA channel, though the labeling is a little odd, so again, we're going to have to figure that out. Of course, like the IR receiver, it's got a bunch of Tandy-specific gals on there, but the Save It interface is interesting because this is what allows you to initialize a Save It card in your PC, and also what allows you to write bootable code to a Save It card. So the only way you can make a bootable Save It card as it existed then, and right now, is to have this card, put it in your PC, get your executable code on there, and bless it with the make-tat-m utility. We may take a look at that. I'm really hoping to play with that. And this allows you to boot small MS-DOS applications, whatever you can fit on a 32K Save It card. And this was actually also used in the diagnostics of the machine. Early pre-release versions of the BIOS did allow for the BIOS itself to boot unblessed code, so code that didn't have a TAT file, from the Save It card in place of the operating system. Now this was turned off in the release ROM, and we could confirm this with the release notes and the ROM's functionality, but that functionality did exist when they were testing. This allowed them to test the ROM itself and some diagnostics and factory diagnostics and the like. You'll notice there are two empty sockets on the left side. Those are empty in every example of this card that I've seen, so I don't know what would have gone there, and again, we don't have the documentation. And of course, on the left you see the CD-ROM interface. And I know some of you are going, that's an IDE interface. No, it's not. It's an IDC 40-pin header. This is, in fact, a derivative of the Mitsumi interface. Now, if you remember back in the day where there were a handful of different proprietary interfaces like Panasonic, and I think Sony had one, and one was Mitsumi. This is not ATA or ATAPI or IDE. It's not at all like it. This, though using the same 40-pin IDC connector, is a proprietary interface. I have done some testing on my Tandy 3000 NL to confirm that the CD-ROM drive is Mitsumi-ish, but the drive in the VIS, at least, doesn't respond in a way that the standard Mitsumi drivers like. We may revisit this little facet as well, but if you do have a CD-ROM drive, it will connect to this. Now, whether this takes a VIS drive or a standard Mitsumi CD-ROM drive is yet unknown, but it is something you know we'll play with. Next up is the VIS audio card. In fact, I've removed the Sound Blaster from my Tandy 4833 so we can put this card in. This is basically Tandy's implementation of the AdLib Gold as it was used in the VIS and in the Tandy Sensation. It doesn't do anything different than most AdLib Gold cards of the day, and of course, as you remember, AdLib Gold went belly up right around the time the Sensation and the VIS came out. Tandy, for the Sensation, did whip up a Sound Blaster-ish emulation layer, but either way, this card should allow VIS-like sound functionality if you're testing your VIS applications on the PC, and we'll definitely be giving this one a try. And finally, we have the VIS video card. As you recall, the VIS uses the same video that was used in the original Tandy Sensation. I won't repeat the catalog number again, I've said it like 3 times already. This card has S-video and composite outputs and allows you to run VIS video out directly to a television screen or VCR or what have you. This card is just like the Tandy DAC that was in the Sensation in the VIS and should function in exactly the same way. It has the same ROM and limited video mode support that is found in the VIS. So this is not a straight VGA to RF card, even though the Tandy Sensation DAC and the VIS support VGA and EGA modes in a limited fashion, as we've discussed. So that's the video card. We will definitely be playing with this. And first up on the bottom row here, we have a collection of Save It cards. This first one is a retail unit. This is the same 32K card that was sold in Radio Shack, and pretty much anyone you're going to come across, whether it be in eBay or any place else, is pretty much going to look like this, because this is the one card that was available for the VIS. Next to it, we have a generically branded Dallas Cyber card. And this card has hand-labeled Diag card number 3. I believe, though can't tell yet because I haven't tried out the Save It card interface, that this card contains code that allowed the operating system to be booted from this card rather than ROM within the VIS. This would have been an early Diag. Now, the BIOS functionality for booting an unblessed card has been disabled, and this card does not boot in my VIS. Therefore, I know that this card doesn't have any MS-DOS application on it. Now, if you take a closer look at the card, you'll notice that it says DS6417-256. I know what you're thinking. Oh my God, TJB Chris, you've got yourself the 256K card. Nope, unfortunately I do not. This is in fact a 32K card, 32 kilobyte, as in this is 256 kilobits. And conveniently, 256 divided by 8 is 32. So this is a standard 32K card. However, this is a standard Dallas Cyber card were it not branded for VIS. And finally, we have two more generically branded Dallas Cyber cards, same model number, DS6417-256, so they are 32K cards. The next one doesn't seem to have anything meaningful on it. Maybe it was another Diag card, but I've not looked at it through MC Man or anything like that, but it certainly doesn't boot. So there's not really anything to look at there. Maybe we'll find a save file on it or something fun when we look at it in MC Man. And finally, on the right is one with a handwritten label that says modes on it. And we'll be taking a look at this card a little later in the video. It's kind of fun. And there you have it, friends. Those are the VIS development cards, and they're here in my computer room. Even if temporarily this is really amazing, it was worth me going out and buying this craft board and making the labels and gussying it up real nice, because honestly, I can't believe they're here. And again, I can't thank Tandy Showcase enough. There are not lots of these cards, so please don't reach out and bother Tandy Showcase about these. But it is really generous, and I appreciate the ability to start to learn these cards and show them off to the rest of the world and see what VIS development was like. And we're going to figure this out together. So next up, we're going to put this serial loader and its matching riser card into the VIS, and when we're done with that, we're going to break out the DT100, see if we can get some data back and forth, see if the VIS's boot behavior differs at all with that card in there, and we're going to take a look at this card down here, this cyber card that says modes on it, because it is an interesting little artifact, and it's going to prove something out that I'm really not sure if it was going to work. So let's get my VIS, let's get it apart, and let's get that serial loader card installed. Okay, the VIS has two screws on the side, so I've got stubby here. And now we can see into the VIS, and I'll tip it up here so you can see what we're looking at. And of course we've got, you can see here on the back, we've got this expansion slot. This is where the serial loader card is going to go. This is where the modem goes. And of course here we have our expansion slot. And we're going to install the riser card is going to go in the slot this way here. And it's actually going to go attached to the serial loader card. So we're going to attach the serial loader card, slide it in, and then we'll install the screws in the back side here. So let's do this. This thing already has a blank and my existing screws in there. Let's get those out. Oh, I should bend it off of there. Okay, had to bend it off. It's actually attached to the one next to it, so you have to kind of bend it. All right, let's put my screws back in so I don't lose them, because this debug card is going to go back to its original owner someday. No, it will be going back to its rightful owner, so we'll keep my screws. And now what we have to do is take the serial loader card here, which we have. We've got this little connector here. I'm going to attach this little riser. And now we have the riser attached. I'm going to remove these. Apologize if there's glare. We're trying new lights out, friends. I'm trying to do the best I can with lighting in a small space, and I'm hoping that these are better. Let's Channels sure don't make money, friends, but it is a lot of fun. Okay, here we go. So now I should be able to slide this in, line it up with this here, the slot here, and slide it in, aligning the expansion slot, and we should be in pretty good shape. So let's see how this works. Oh, it lines up really easily, actually. Look at that. And we're in. All right, now we just got to line up some screw holes here. Oh, there they go. All right, let's see if we can do this. And there it is, all reassembled. Really cool serial port in the back. These lugs weren't here, and honestly, I don't know that they ever were. There's no where to indicate that there were ever lugs there. So, I'm going to get this hooked back up to the television and go from there. All right, here we are back in the mission control setup, kind of. The 4833 isn't back here yet. And of course, the VIS is set up. The TV is on. So let's flip over to the VIS now that we have the serial card installed and see what, if anything, happens. All right, here we are. Let's just power it up and see what she does. Huh. Well, that's different. If you remember from the previous videos, it does the nice little VIS splashy logo. Instead, we have Haiku Remote File System, Transport Layer Found. MSCDEX, looks like CDS. Look at my laptop over here. Yep, CDS. Got OBS over here on the laptop. MSCDX, CDS located. CDs? Does anything happen if I put a disk in? Here. Here's a bootable disk. It did something. It's reading it, but I can hear it. But it didn't do anything. Okay. This is an interesting thing. Now I know, put my elbow on the keyboard here, I know for a fact that the Shell Lite application I'm hoping to show you tonight will use the transport layer, that card, to send logging information out to the terminal because it mentions the command. So it's at this point in the video I think we need to stop and R the effing M. See friends, this is a reshoot. I'd actually shot about 5 or 10 minutes more footage, or I poked around with the DT100 and then kind of looked around at some other things to see if I could just get some handshake bites back and forth to see if anything was happening. And then I kind of stopped there, ran out of time, and said, well, you know, we'll address this next time, and next time could have been the next day. Well, then I got busy. And while discussing this with some other folks, I was reminded of the M and the fact that I should R the effing thing. And this is the thing, you get so enthusiastic, so excited, especially these rare unicorn cards and cool stuff we haven't seen, I've never seen, and none of you watching have probably ever seen, unless you worked at Tandy in 1992. So, and even some of the people that saw that then are no longer with us. So, you want to plow ahead, but sometimes in doing so you forget the simplest of advice, and that's R the effing M. MFer. Right? Right. So that's what we're going to do. And to move ahead, having R'd part of the effing M, we're going to need the 4833 back, so I'm going to do that now. Let's get the 4833 back on the table, and then we're going to bring up the manual and dig into this thing for real. Alrighty, 4833 is back in action, and I love using that little Scrabble thing for montages. It gets them over quick, but it's a whole lot of fun. I love that sound. It's one of those childhood things that just kind of sticks in my brain. Anyway, we've got the modular Windows manual loaded, so let's do the obvious thing that I should have done the first time around and just search for serial. Let's do that. And immediately we're taken to a page that mentions transport layer services that are included with modular Windows. Now, you'll recall from a previous video, we've already installed modular Windows on here, so these binaries are in place and ready for us to use. And then it also mentions a few other debug utilities that are available for modular Windows. There's the Windows 286 debugger. There's a utility called DOSMon, that we'll be using in a future video when I talk about developing for DOS-based applications for the VIS. And there's some other bits in there too, but what we're really interested in is the transport layer server and the redirected file server, RF server. And this page of the manual refers us to the programming guide for detail. So let's flip over to the programming guide. Now I've got the programmer's reference above my head. Let's just search for the TLTSR, now that we know the name of the thing. Should take us right to where we want to go. And there we are. It takes us to Chapter 9, Tools. So now if I look through Chapter 9, of course, it mentions again RF server, the TLTSR, some of the other debugging and monitoring utilities that we won't be using just yet. And it also mentions an application named NOECHO that I think we're going to want to play with as well. So let's go to the next page, assuming I can get this thing to go to the next page. There we go. And this gives us a bit of copy about, debugging applications for a set-top player. When you've got a CD-ROM-based thing, and either mastering disks is painful or expensive, or you just don't want to waste that many CDs, you want a way to test your application changes on the player, get the updated files there without having to master a new disk every time. So this is where the remote file system comes into play. This allows you, once you've moved on using the other development cards to test the application in your PC, you really want to run it on the real hardware, this is your bridge to do that over the serial port. So the first thing we have to do here in taking a look at this is look at the transport layer. We got to start that. So let's do this. Let's exit Windows. It's probably within modular Windows. Let's go to ModWin. We installed that in a previous video. I believe TLTSR.star should be in here somewhere. Yep, okay, perfect. ROM utils. Played with this a little bit and then moved on. So just do that. And if I take a directory, oh yeah, here we go. All the utilities that were mentioned a couple of pages back. Including NOECHO, we'll talk about later, TLTSR, which is right here, and the RF server, the redirected file server. So let's run the TSR. Just tells us to run it. There we go. We've got the transport layer services. Now we'll take a look at RF server. Now the redirected file server, and actually I can run this and also get some help on it. The redirected file server will allow files in the directory branch specified to overlay on a remote CD-ROM. So this allows you to add and replace files, it says. And we can add, delete, and modify local files. Now the important caveat here is this says is it looks like for VIS to recognize any changes, we have to reboot after we make any changes in the directory. But that's a small price to pay versus making a CD-ROM, right? And the VIS boots pretty quick. Files in the directory path, so the one I specify, will appear in the root directory of the remote CD-ROM. Noted. Files in directories below path will appear below the root directory on the CD-ROM. So for example, if you have like a bin or something. Okay, so I have here actually a directory where I've been developing some little utilities and things for the VIS. So, like to get the version number out and play with hand control and stuff that you'll see in the next video when I talk about MS-DOS development. So actually, we're going to need to take a little preview of that. So let's start the RF server and see what we get. So if I do RF server, and I want to display the messages, that's going to be kind of useful. We'll do that on TSR version. Imagine this will make it easier if I want to exit and change paths. And then we want to go C:\source. Press X to exit. Okay. Well, now this takes us over to the VIS side of the show. Before I move on, is there anything else I need to know? Let's see. Before we do move on, yeah, start with the current version of your application disk. That's the interesting thing. You got to have a current version of your application. As you're about to see, nothing will happen on the VIS, even if I have this loaded, if I don't put the disk in. Serial link's not as fast. Don't run protected mode software such as Windows on your host machine. Noted. If it hangs, restart, redirection should resume. And always keep a disk in the drive even if all of your files are redirected. It says the CD-ROM driver requires a disk in the drive. Okay. So that pretty much leaves us to getting to the VIS. But how am I actually going to make use of these redirected files? Well, folks, that brings me to a little mini shell of sorts. I mentioned it a little earlier in this video, and I've hinted at it elsewhere. If you remember from my previous videos on the subject, or if you saw my TA talk, my Tandy assembly talk, I've been harping on the fact that there is no command.com interpreter in the VIS. Built into this VIS, there is no command.com interpreter. Now, fun fact, if you go through the ROM table of contents, you will find a binary named command, but it is not a command interpreter. It doesn't have, if you were to look at it, you wouldn't see any of the usual things that you would expect to find in a command interpreter. In fact, it makes reference to VIS BIOS, which is the VIS BIOS extensions to support the VIS's hardware, and if you run it, it will crash the VIS, and when it reboots, it'll get really glitchy and you have to power the thing off. But what if I need something that's command.com like? Well, that brings us to browse.com. So let's flip over to the VIS and take a look. Now, browse.com is a mini shell. It looks a little like command.com, doesn't actually do anything. Now, as you can see, the VIS isn't booting. It's still sitting here waiting for waiting for a disk or something else. We saw before it didn't read the disk, it didn't do anything when I put the disk in. Now I've started the redirected file server over here, but I've not actually rebooted the VIS. So what I'm going to have to do is reboot the VIS, and what I'm going to actually reboot it, and I'm going to flip back over to the PC real quick so that you can see some of the files scroll by when I reboot the VIS. So let's do that. All right, with everything started, I should just be able to reboot this, and once the transport layer initializes, it should grab its files from the other side. There it goes. And now we get the boot splash. So there we are. And now that we've booted up, let's take a closer look at Browse. Now I know what you're saying to yourself. Well, TJB Chris, you just said there's not a command com on there. I think you lied. That looks like command com to me. Looks like it until you dig any deeper. It looks the part until, well, it doesn't. So what I have in here actually is the CDG disk, which is just a disk with a beta CDG player. And it has the browse.com shell and almost nothing else on it. And this was in the 5.13 archive from Frank Doherty IV that has been floating around Discord. So here I can take a directory, and you can say, oh, it's got a directory. It really looks like MS-DOS. Looks like command.com. Meh. So there you can see some familiar files, control.tat. There's a mouse, or browse.com, that's this. GoROM.com, which you saw from the other side. We need that. And this file big, which is big, I guess. Either way. So if I type help here, though, this is where things really start to become clear. It's obvious that this isn't your father's Oldsmobile in terms of command.com. I can clear the screen. Whoopee. I can do a directory as I've just done. I can change my directory. I can exit, which will reboot the VIS because it's the last. Browse.com is the last thing listed in control.tat. I can try and execute from a card. There's no card in there. And the last three are some of the more interesting ones as it relates to the transport layer. I can log on, turn on logging to the serial port, or I can turn logging off to the serial port. So whatever I type here and whatever comes back will log. Now, I've mentioned in the past, again, too, that the VIS doesn't have a text screen. I know, this looks kind of like a text screen. This is actually a graphics screen with a crude character set. So this isn't mode 3, like your 80 by 25 mode that you'd find on a DOS machine. But they did kind of put this in here, so you can use a graphics screen as a text screen. It's really crude. It can't render tabs or anything else. It's not great, but hey, it does the trick and allows us to poke around. Okay, so I noted here from the documentation that the files in the directory I specified, c:\src on the 4833, should appear in the root of the CD-ROM. There really are no files there. What I don't know is if I have any files in the root of the CD-ROM. And in fact, there are a bunch of directories. We saw the file list go by, but none of them actually appear there. And I don't even think I can change to them. Let's try. Yeah, nothing. So that is a directory within c:\source. So now this puts us in a little bit of a pickle. Let me see if I have any files in source. I'm just going to hit X to exit this. src. I don't. Let's do this. Let's just for the sake of experimenting, I'm going to create a tjbchris.txt. Hello, you rummy buzzard. File save, file exit. Okay. All right, let's restart this. Okay. Now, I'm going to go back to the VIS here. Now back to the VIS, I'll give her the 3-finger salute. Bunch of files roll by. VIS starts to boot. That's good. You're seeing it boot up. Okay. And I still don't have it, so that's interesting. DOS's directory doesn't see the file, but that doesn't mean it's not necessarily there. So if we look back at our help, if I try and cd to VIS utils, doesn't want to do that. Okay, so let's do this. tjbchris.txt is there. So maybe this is just browse.com being strange. So let's do this. Let's dump tjbchris.txt. Now, I don't have anything on the PC side listening for the serial port. We'll get to that. But let's see if this at least is successful. Okay, it does say successful. And if I look over at the PC side, you can see it opened the file, it read the file, it closed the file. Now, just to make sure that this isn't a red herring and it's just going to say it's successful anytime, let's try and dump a file that doesn't exist. So in this case, we're going to dump ass. And the file's not there, nothing happened. And if I look back at the PC, I shouldn't see any output on the screen. Yep. Okay. So what this tells me is that I should be able to run the other utilities on here even if I can't change into the directory. So let's try that. So in my source directory, I have a VIS utils directory. And I have a utility I call VISFIR, which just extracts the MS-DOS version number out of the ROM via the regular calls. And that did work. And you can see it here on the PC screen. Let me flip you over to the VIS so you can see what that actually looks like. And there it is. So there we go. And yeah, it reports as DOS 3.22, but don't get your hopes up, it's different. But that's it. It does actually read the files. So I'm going to do this. I want to set the PC up to be in daemon mode, essentially, TSR mode. And then I can look around the directory, make sure I can kind of poke around and see what else is in there and try and run some stuff. So let's do that. So let's X to exit. I'm just going to take out I'll take out -M and -N. It won't put any messages up on the screen, but who cares, right? Now if I go source, of course you can see I've got my files here. Let's see, I'm not doing VIS card. Let's go to VIS utils. We'll just poke around in there. Okay, VISDIR. Oh, I did write the directory thing. Let's see if my directory utility sees it. That could be fun. So I wrote a little directory utility. I was trying to prove out in some discussions that there's not a C drive on this thing, right? There's no other drives. So I made a bunch of utilities to go query the BIOS for the drives and list them, do the DOS version number. And I also wrote one that goes and walks through the directory itself. It doesn't rely on browse.com because I wasn't sure if browse might be doing a little trickery in terms of what I can and can't see. So I've got VIS utils VISDIR I think star will do it. Okay, it still doesn't see it. Can I do, since I can't change this, it's much more difficult. // VIS utils. Yeah, error reading it. Okay, interesting. So the redirector is interesting here in that the files are there if you try to directly access them. Like if I open up any of these, like VISDIR ran from in here, but it doesn't actually, I can't actually find it by listing the files in the redirector. That's interesting. Okay, so that's an interesting little thing. And of course I have another one here. So I have a save it card, and I have one, and you'll see these more in the next video where I kind of walk through doing all this various bits here. If I VIS utils, what do I call that? Card size. And now this just read off of the PC. And I just wrote a little thing to go out and tell you how much ROM and RAM is on a save it card and how much there is free. And it's card ID, which I've not found any that are 0. And we'll take a closer look at this when I do save it cards in a future video. But okay, so that's the file redirector. But if you're writing an application, right, and you've already got, like they tell you, you have to use an application disk. If you've got an application and the redirector will supplant and add to any of those files you create, you can modify the files you want, recompile if something doesn't work, and then come back and have the redirector run it over the serial port. Slowly, but at the very least, this saves you burning a disk and will save you a lot of time, which is really freaking cool. And this, it's too bad this serial card is unobtainium, because this would be a boon, would certainly be a boon to me when I'm trying to write stuff for this. If you saw my TA video, you're already aware that I have ported a game here. It was an easy one. But I have ported a game over here, Commander Keen and Keen Dreams. It's not on GitHub just yet, but it will be. I'm going to cover that in the next video along with some other interesting facts about porting software to this. But without this functionality, let's just say I made a small landfill full of coasters, but getting this thing to work. And so this functionality will go a long way. But wait, folks, there's more. We did see that NOECHO utility. Let's go take a look at that. So the NOECHO utility allows you to view debug messages that are sent out through the card via either the logging, or there's some functions you can call, like output debug message or something like that. And so what I do with this is I'll come over to the PC, and we're going to go back to modwin rom utils, and I should have NOECHO in there. And if I run NOECHO perfect, it runs. Now this can coexist with the transport layer and the redirector by all looks. So now, I mentioned before, let's go back to the VIS, that we had log on and log off, and we had dump. So let's do this. Let's dump tjb chris text. It did not do it. That's interesting. I'll show you what we got. Oop, there we go. Nothing. Just out of curiosity, let me just turn log on. Oh, there we go, logging to com1. So now you can see what I'm doing. Now what happens if I do a dump tgb chris.text. Yep, there we go. Oh, interesting. So logging has to be on. You've got to have your log on before you can take a dump. Noted. And of course, again, if I try and dump AS, we're feeling a little punchy here this evening, friends. There's no AS to dump. Well, that's probably good, considering this would not be the right place for that. So, and again, now if I run my VIS utils, VIS vir, now you're watching it on the PC, except that my application doesn't output. It uses the BIOS calls to write directly to this graphics screen simulating a text screen. So the output from my program doesn't come out here. You have to use the correct functions to get that to work. But that's where browse.com does use that. What is it? Output debug. Let's look at it. Output debug string function. So that's interesting. And it actually, I just realized in the ring the FNM, to run the NOECHO command, you must start the transport layer, and then it can be run in conjunction. So there you go. And I'm guessing that the dump command here is dependent on browse logging out to the serial port for you. Because if I turn off log off and I dump tjb chris, not ump text, it did it. You didn't see me type it. Let's just go back to the VIS here and you can see it. There you go. It finished it, but file's not there. So still very cool, and this gives you the ability, if you have an application you're trying to run and you want to get some debug messages out where you don't have a console, right? You're in a graphics application, you're trying to run something, you don't have a way to put it out, or you don't want to draw dialog boxes and crap. You use that output debug string function to feed it out to your serial console on a connected PC. And all this while redirecting your file system so that you can change your application when it doesn't do what you want. So that's pretty cool. Honestly, this serial debug card is like I said, a great boon unto development, if only there were more of them. But it's still fun to play with, folks, and I'm really glad I had the opportunity. And this actually will be, in the next video when I talk about developing for VIS, we're going to do it the way I usually do this. I'm going to walk you through, and we're going to talk a lot about the hardware and some of the differences and things, and walk through some of that. I'm going to walk through porting an application for you-ish. But you'll get an idea and a sense of what has to happen. But then we're going to try and dump over to the serial port here, and maybe we'll demonstrate how it would be easier if I didn't have to burn disk every time I changed the application. So what's next? Well, as Billy Mays said yet again, but wait, there's more. Well, we've covered this at least in a little bit of detail here. I'll probably be covering it more again in future videos. I also wanted to touch on a little bit of bonus content for you, because I've surmised about Save It cards, both at Tandy Assembly and in previous videos, and some of the capabilities that are on retail VIS units, and it turns out, thanks to this very generous loan out and the cyber cards I got, I now have my answer. All right, in the bonus content department, we're going to need this Save It card. This cyber card, this is one of the generically branded Dallas cyber cards, has handwritten on it the word modes. And I got this card and it got me to wondering. Now, modes is an application that allows you to do some video display testing and test out the various modes, see how they render on different television sets and displays, things like that. It's in the archive. You could make a bootable disk with it with a control.tat or use browse.com, and go run it and play around with the video modes. So it's curious that it would be on a Save It card here. The documentation that we have from the archive clearly states that from a BIOS standpoint, booting from a Save It card is disabled. Now, I've seen some references to this in some of the source code that I've come across as well. However, the screen you're looking at now, where you're looking at the VIS boot splash, and it says insert a disk or cartridge, that's not the BIOS. By the time you get to the screen, DOS, Haiku DOS, is running. And you're actually within a Haiku DOS application called T-Launch, which is one of the many applications that's listed, one of the binaries listed in the ROM table of contents. And there are utilities for blessing binaries to run with a TAT file. There's a make TAT-M, which will make a license file for a Save It card, will then tell the Save It card how to boot. Now, fun fact, the Save It card only knows one executable file, that's card.exe. We'll cover that in the Save It video. But that got me to thinking that this modes card might be bootable. Well, let's pop her in and see what happens. I'm going to try and get this in loaded and pushed in quick. It's a little picky. And it crashed on me, but I'm just going to give it a reboot here. Okay, here comes Boot Splash. And it's booted. You don't see much, but there's a little graphic screen cursor in the bottom left corner. And I just ejected the disk to show you there's no disk in the drive, friends. This is booting from the card. So this proves it. You can boot from a Save It card. Now, what was disabled was the ability to boot an operating system from the BIOS, or something like a factory diag or something like that, which would have loaded pre-operating systems. So you could test the hardware, or test early versions of some of the operating system binaries, things like that, when the ROM either isn't final or you want to override it. So now that that's finalized, they took out the boot functionality for the ROM BIOS. But the comforting part is you can still boot from a Save It card. Now, there are some really big caveats with this. And so this does not a panacea make as it relates to VIS development. And we'll see why when I get to the Save It card video. But let's take a look. So I've got my vertical modes, I've got my horizontal mode. There's a bunch of other things you can do here. So you can see I got 320 and I got 200 lines. And there's a way to run 640 by 480, or 640 by 400 modes, and other things like that. It's a pretty simple application. That's pretty much it. It's more comprehensive than this. There's some doc in it floating around the archive, but this is a booted application, an MS-DOS program running from a Save It card. So now we know that you can, in fact, run applications from the Save It card on the VIS, though its usefulness is admittedly limited. So anyway, more on that when we get to Save It cards. I do intend to try and make a bootable Save It card when we get to that. So where does this leave us? Well, friends, I think this leaves us in a really good spot. So again, having not R'd the effing M the first time, I didn't spend a lot of time digging around. I just kind of poked around a little bit in some of the files and things. Now I'm going to have to go read the manual, and I think I said something along those lines in there. And then, yeah, I wished I had. I did poke around with the DT100 in there a little bit, like I said, just to see if I could get like the handshake string across it to see if anything was coming along. I did actually try using the log command to log straight to the DT100, but it turns out there's two problems with that. As we've now demonstrated, this has to go over the transport layer, so you need the transport layer side on the PC. The DT100's dumb, it's not going to know any of that. The other is it runs at 115/200 baud. The DT100 caps out at 38.4 anyway, so that wasn't going to happen. And again, if I'd R'd the effing M, I would have known that. But hey, this is the fun of learning about this and doing it, and sometimes it's a good reminder to me that sometimes when you get a little overly enthusiastic, the best thing you can do is put it on the brakes and slow the hell down, because you might miss something. And so I'm sure the individual who is nice enough to be, hey dude, it's in the manual, takes great pride not only in having been able to give me the snark on that one, but also watch me eat some crow about it. But this is public. I could have said nothing and pretended, but I make mistakes too. It's part of the fun of being this channel. Well, friends, so next is going to be DOS development. I'm going to focus on what I've done. I've mentioned Commander Keen. What led to Commander Keen was a bunch of skeleton applications that I kind of played with in a bunch of different languages, and some little utilities I wrote for exploring the VIS's capabilities and DOS's capabilities. And we're going to walk through that. I'm going to talk to you about developing, using my 4833 to write code, getting it over to the VIS without the magic unicorn cards, and kind of what that process was like. We're going to talk about some pitfalls for writing applications for VIS, importing DOS and other applications over to it. It's not just a straight port. And then we're going to do a little bit of a demonstration on some of these applications that I've gotten to run. So I think it'll be a lot of fun. There's a lot to the VIS. There's a lot of caveats. We're going to talk about programming for the hand control, and that's going to be, I think, quite a bit of fun. So please stick with me for that, and we're going to incorporate the serial debug card in there, and I'm hoping I can also incorporate the other development cards in there, but depending on how long the next video gets, I might take those into a separate video and start to put them in the 4833, and maybe we'll explore those separately. And then again, down the road, I also have a little bit of talk to do on the Save It card, so we're going to talk into some detail writing for that, how it's formatted and how it works and things like that, and maybe we'll even try and make ourselves a bootable one of our own. So lots of fun for a niche topic, right? Right. So for those of you who are sticking with me, I really appreciate it. I'm glad you're here. I hope you find this interesting. I'm hoping that the unicorn cards and the idea that we're getting to play with something that you're not going to see on anybody else's channel. None of the big guns have any of this yet. That, at least if they do, they haven't put it out there. And it's something unique, and there are very few times I get to do something really unique on this channel that somebody else doesn't have. So it's kind of nice to play with this, and it's really neat to explore a little piece of Tandy that I think is underappreciated. And quite frankly, it's a bit of a fascinating piece of hardware, especially given its place in Tandy's history. So I'm really glad you're here. I know this is small potatoes, not a lot of folks watching because this isn't, you know, some sexy topic, but that's kind of how I like it. Welcome to my little corner of the internet, folks. And from my little corner of the internet, I'll thank you again for watching, and I'll see you next time.